dear learners. I welcome you all to Math Online class. In today's session, we shall continue the chapter Algebra, and we have already solved out some problems, some word problems, and we are familiar about formation of algebraic statement. Let us continue with the word problems. The 11th word problem. Look at the following matchstick pattern of squares. The squares are not separate. Two neighboring squares have a common matchstick. Observe the pattern and find the rule that gives the number of matchsticks in terms of the number of squares. Hint: if you remove the vertical stick at the end, you will get a pattern of C. So let's see this more in detail. Here there is a hint given for us. If you remove one stick, we will get one stick from vertical side, we will get the pattern of C. So before that, let us see how many sticks are there in each. So 1, 2, 3, 4. First one, there are 4. The second one, 1, 2, 3, 4, 5, 6, 7. So second pattern, 7. Third one, 10. And fourth one, there are 14 matchsticks are there. So if you remove, as per the hint given, if you remove one from each pattern from vertical side, we will be getting 3, 6, 9, and here it is not 14, there is only 13 sticks. So if you remove one from the last, we will be getting 12. So here what we see here, we see the multiplication table of 3. So that means 3 times 1 is equal to 3, then 3 times 2 is 6, then 3 times 3 is 9, then 3 times 4 is equal to 12. So this pattern we get when we remove one stick from vertical side of each pattern. So according to this, for n to 1, the rule will be 3 times n, or whatever if you take the variable x, we can write this as, if you use the pattern x, we can write instead of n, this will be x, 3 times x, and so on. But in fact there are 4. So this is 4. Just to make some arrangement, we removed one stick. If you remove one stick, we will get the multiplication table of 3. So according to that, 3 into 1, 3, 3 2s are 6, 3 3s are 9. And as per that, if there are if in the xth pattern, it will be 3 times x. So in fact there are one more stick. In fact there are 4 sticks in the pattern. So we will write this as 3 into 1 plus 1, then 3 into 2 plus 1, then 3 into 3 plus 1, 3 into 4 plus 1, and last one 3 into x plus 1. Look at the 3 into 1 plus 1. That is the first one. 3 into 1 is 3, 3 plus 1, 4, exact 4. And here 3 into 2 plus 1, 3 2s are 6, 6 plus 1, 7. Third one, 3 3s are 9, 9 plus 1, 10. Fourth one, 3 4s are 12, 12 plus 1, 13. And if the xth one, if there are x matchsticks are there, that means one remove 3x plus 1. So the general formula of this pattern is 3x plus 1. So 3x plus 1 is the general rule for this matchstick pattern. So this is the answer for this question, 3x plus 1. See the next pattern. Here we have triangular pattern. So first one, there are 3 matchsticks, and the second one, there are 5 matchsticks. If you count, you can find here 3, 1, 2, 3, 4, 5. Then next one, there will be 7 matchsticks. You count it, 1, 2, 3, 4, 5, 6, 7. Then the next pattern, there will be 9 matchsticks. So if you take away one from each pattern, so this will be 2. If you take one from 5, this is 4. If you take one from 7, it is 6. If you take one from 9, it becomes 8. So we find that it is the multiplication table of 2. So multiplication table of 2, we can get this as 2 times 1 is 2, 2 times 2 is 4, then 2 times 3 is 6, 2 3s are 6, 2 3s are 6, then 2 4s are 8. But if there are x matchsticks, the rule will be 2 times x, and so on. And here in fact there are 3 sticks. For making the rule, we just removed 1 stick from each pattern. So it is actually 2 times 1 plus 1. Look at the 2 into 1 is 1, 1 plus 2 plus 1 is 3. And here 2 2's are 4 and 1 more is there. So that then only it becomes 5 matchsticks. And here similarly plus 1 will be there. Then plus 1 at last there also plus 1. Then only it becomes 2 into 1, 2 plus 1, 3 sticks. 2 2's are 4, 4 plus 1, 5 sticks. 2 3's are 6, 6 plus 1, 7 matchsticks. 2 4's are 8, 8 plus 1, 9 matchsticks. Then according to that, the last row, the general rule, 2x plus 1 is equal to, that is the general rule of this matchstick pattern. Here you see again the variable and pattern. In the beginning, the first class itself, we learned what is a variable, an amount that can change. Letters are used as symbols to represent variable. So the last one we got 2x plus 1. So this x will change according to the pattern number. For the first pattern number, x will take the value 1. 2 times 1 into 1. So we will get 2 into 1 is 2, 2 plus 1, 3. For the second pattern, instead of this x, we will give 2 plus 1. So only this x will change. See, only the x values are changing. The other numbers 2 and 1 is same for all. So for the second pattern, 2 into 2, 4, 4 plus 1, 5 matchsticks. Look at the 5 matchsticks. So x is the variable which can undergo for changes. According to the situation, it will undergo for changes. See the next one. Next we are beginning the second exercise. The side of an equilateral triangle is shown by L. Express the perimeter of the equilateral triangle using L. So the 3 sides of equilateral triangle, taken the side as the variable L. So we know that we learned the perimeter. Perimeter is the length around the boundary. So if you add this, 3 edges are each L units. So the perimeter, in order to get the perimeter, we have to add the 3 edges. So 3 L's. So the perimeter is 3 times L. So 3 times L is 3 into L. So 3 into L is 3L. So 3L is the perimeter in algebraic statement, algebraic expression form. This 3L is the formula for finding the perimeter of equilateral triangle. Similarly, one more, the same model, the side of a regular hexagon is denoted by L. Express the perimeter of the hexagon using L. A regular hexagon has all its 6 sides equal in length. So similarly, as we had seen in the case of equilateral triangle, in order to get the perimeter of regular hexagon, we need to add the measures of all the edges. So there are 6 edges. So 6 times we have to add L. So 1, 2, 3, 4, 5, 6. So 6 L's are added. 6 L's means 6 times L. So 6L is the formula for finding the perimeter of regular hexagon. I hope today's topics are well understood by you. Thank you. Have a great day.